All right, welcome back to Calculus 2. We are continuing dealing with method of shells, and I'll show you why we're dealing with method of shells for this. Um, it's figuring out the volume of revolution of the area bounded by y equals x squared and y equals 4x minus x squared about x equals 4 and y is equal to 0. Let's draw a picture. Okay, so figure out what we're actually doing here. Okay, we know that y is equal to 0, so that gives us a lower bound for our idea here. So we're going to be able to make a parabola, y equals x squared. We can go ahead and draw this guy up here. Okay, but 0 would start with 0. And then we have 4x minus x squared. Well, this is a parabola that's like upside down. So we'll go ahead and figure out this. So we're going to say this is 4x minus x squared equals 0 and see what this happens. So we have an x, 4 minus x equals 0. So we have x equals 0 and x equals 4 as far as what's going to happen. Here's this one. Let's go ahead and separate this out a little bit more. Okay, draw this out. Okay, so here's 4. Okay, we'll say 3, 2, 1. Okay, we'll have that figured out that way. Okay, so we have x equals 0 and x equals 4. So we have our parabola facing like this, right? Next thing I need to know, because I don't know where this parabola is. I know it's a parabola facing down, right? And our intercepts are going to be here. So our vertex is going to be between 0 and 4. It's going to be 2. So we're going to be up here somewhere, okay? So we're going to be something like this, okay? Now, the important part for this piece, and I probably didn't draw this quite right, so I'm just kind of I sketched it in to kind of get an idea for it. But the idea here is like um, somewhere this x squared and this 4 minus x squared are going to swap positions. Like one's going to be on top and then the other one's going to be on top. And it's going to be kind of weird to figure out like what's going to happen here. Okay, so we're probably going to have something like this. Okay, so things that I want to know is where do they actually intersect? Because I'm going to have to figure out like if I'm going to take my little strip here, right, and revolve it around my x equals 4, I need to know which function is on top and which function is on the bottom. Because if I take it over here, right, my height's going to be the x squared minus this piece here. It's going to swap somewhere in the middle. So we kind of have to know where that middle is going to be. So how do we know where two functions are equal to each other? Well, we set them equal and solve. So we could say, okay, where is 4x minus x squared, right, equal to x squared? Okay, and we have to go ahead and solve this. So let's go ahead and add our 2x squared, or add our x squared to both sides. So we have 4x equals 2x squared. And then, of course, I got this out of a textbook. So, of course, it's going to come out nicely. So we have 0 is equal to 2x squared minus 4x. And we can figure out what's going to happen here. So the first thing I'm going to do is pull out a 2x, right? Because that'll take care of that piece. So we have what's left, x minus 2 is left. So we know they intersect at 0 because 2x equals 0, x equals 0, and x minus 2 is equal to 0, x is equal to 2. So this is a kind of a crummy picture, but that's where they intersect. Okay, so let me see if I can't straighten this thing out a little bit. I should just draw a better picture sitting over here. Okay, 1, 2, 3, 4. At x equals 2, we're going to have 1, 2, 3, 4. So we'll be able to do something like this, okay? And then this will just keep going up, okay? And then this piece here will come up. So x equals 0. It'll come up when x equals 2. That'll be the top of my parabola here. There it goes, and we'll come down over here, okay? But this piece here is going to keep going up and up and up, okay? So we're going to have to figure out, like we're revolving around this x equals 4 kind of a spot here. So if I picked my point over here, we're going to have the 4 minus x squared is the top function, the x squared is the bottom function. And then somewhere, x equals 2, they're going to swap positions where the x squared is going to take over as the top position, and the 4 minus x squared is going to take over as the bottom position. Okay, so the way we're going to have to do this is we're going to have to set this up as two integrals. So we're going to have 2 pi. And again, we're going to be 4 minus x because we want our radius, and it's going to be 4 minus x for my radius. So we're going to integral. Let's go from 0 to 2. And here we're going to have 4 minus x. Now, from 0 to 2, which is the top function? It's the 4x minus x squared is the top function. 4x minus x squared is the top function. And then we have to have a 2 pi. And we're going to go from 2 to 4. But now I know my x squared is the top function minus the 4x minus x squared. Okay, I did something wrong here. Let's see, we have 4x minus x squared minus 2 minus x squared. So minus x squared here, dx. Okay, at least with this one, it's kind of nice because you don't have to worry about squaring the outside, squaring the inside, and figuring it out that way. It's going to come out to be kind of nice as far as this goes. Okay, so we have, what was this? This was 4x. This is an x squared. So we have 4x. Oh, no, we have x squared minus 4x minus x squared. So let's go ahead and put parentheses so we can go ahead and do that. Okay. So yeah, x squared minus 4x minus x squared. Okay, so we have to kind of break this integral out into two different pieces. So we have the top minus the bottoms and be able to figure out what's going to happen with all of those. So there's a little bit of algebra to go ahead and deal with this thing. Let's go ahead and get this started. At least the calculus isn't going to be too bad. We have our 4 minus x, parentheses, and now let's just go ahead and say this is 4x minus, we have minus 1, so minus 2x squared, okay? Dx plus, and then we have an integral here, 2 to 4. We have an x squared minus a 4x minus a negative, so plus x squared, and this is all dx. Okay, this is still 4 minus x here, so we still need a 4 minus x in all of this case. Right? Let's go back to this. We have a 4 minus x. It doesn't matter which order you write these in. I'm just, putting this together. So we have this. Don't forget the 4 minus x here. Here we go. Okay. No, draw it. There we go. 4 minus x all times dx. Dx. Okay. So that is a mess. Okay, at least some of this stuff simplifies down a little bit. So we could say this is going to be 2 pi, 0 to 2, 4 minus x times 4x minus 2x squared. Okay, dx plus 2 pi. We're going from 2 to 4. And here we're going to have x squared plus x squared. So we have a 2x squared minus 4x all times 4 minus x dx. Okay, so that's a whole piece that we have sitting here. Okay, now let's go ahead. We've got some foiling to do. We've got some multiplying some things out to go ahead and deal with here. All right, so let's go ahead and figure this piece out. So we have 2 pi, 0 to 2. Okay, we have a 16x minus, it looks like we have an 8x squared. Okay, we have a minus 4x squared for this one here, plus a 2x to the third. Okay, and that's this piece here. Plus 2 pi, 2 to 4. Let's go ahead and figure this one out. So we have a, let's say this is going to be an 8x squared, right? Minus a 2x cubed. And then we have a minus 16x. Okay. And we have a plus 4x squared here. So plus 4x squared sitting here. Okay. So just kind of line those up so I can add them up real easy and real quick. I wish we could add these together somehow, but these are different integrals over different regions, so we can't do that. So we're kind of stuck dealing with all of this at the same time, or all of this in different little pieces here. So we have our 16x here. We have minus 8 minus 4, so minus 12x to the squared plus 2x cubed, all under a dx. Okay, plus 2 pi. Here's a 2 to 4. Okay, let's see if we can put this together. We have a, I'm going to say we have negative 16x. It looks like these are added, so we have plus 12x squared minus 2x cubed. Okay, this is all over dx. Okay, I'm going to do one more thing, and I'm going to take, I've noticed a lot of these are negatives. So what I'm going to do is I'm going to factor out this negative. So I'm going to say minus 2 pi here. And when I take out the negative sign, instead of keeping the negative sign here, what I'm going to do is I'm going to take the negative sign inside and swap the order of integration. So notice I took that minus sign out. And then what I did with it was I made these two pieces swap positions. That's a way to deal with the negative sign inside of an integral. This is going to change to a positive number. Now I take the negative out, so we have a minus 12x squared plus a 2x to the fourth dx. Okay, here's my 2 pi, 0 to 2, 16x minus 12x squared plus 2x cubed dx. And now it's just a calculus and arithmetic exercise. Okay, the calculus actually now isn't so bad. It's mostly just power rule. The arithmetic is going to be kind of a pain, but it's not going to be too bad because the twos and fours. But I really wanted to see two things. I wanted you to see when I took the negative sign that I swapped the order of integration. And I wanted you to see a problem like this where the height changes, the top function and the bottom function change position somewhere in the middle of the problem so that you would have a chance to see that before you went and did one on your own. Okay. But the calculus after this isn't going to be too bad. So we just have a 2 pi. Let's go ahead and integrate. So we have 16x squared over 2 minus 12 over 3x cubed plus 1 plus 2 fourths x to the fourth. And this is going from 0 to 2 plus, here's a 2 pi. Integrate. So we have 16x squared over 2 minus 12x cubed over 3 plus 1 half, 2 fourths, x to, oh no, not 2. Does this say to the fourth power? This is the third power. Okay. Fourth, and there's 2 over 4, so that's going to be that one. Okay, and then we are going from 4 to 2 because we had dealt with that negative sign. Okay, so now we've integrated. I'm going to go ahead and clean this mess up a little bit. So we have our 2 pi integral 16 over 2. That's going to be 8x squared minus 12 over 3 is going to be 4x cubed plus 1 half because it's 2 over 4 x to the fourth going from 0 to 2 plus 2 pi. Here we have an 8x squared, 16 over 2 minus 12 over 3 is minus 4x cubed plus 1 half x to the fourth going from 2 to 4. Okay, so it's going backwards. And we're just adding those pieces together. So let's go ahead. Now we've got some arithmetic to do. It's not too bad, but we'll go through and do it this way. So we have 2 pi. Okay, 2 squared is 4. So we have 8 times 4 here. So 8 times 4 minus, here we have 4. 2 cubed is 8. So we have 8 times 4 minus 4 times 8. Well, that's convenient. Plus 1 half. 2 to the fourth is going to be 16. Okay, plus here's my 2 pi. Oh, we have to finish this part up. So if I plug in 0 to all this, okay, we're going to get 0 minus 0 plus 0. So minus, I'm going to go ahead and say 0. The second integral isn't going to be quite so nice. Okay, so we have 2 minus 4. So here we have 8 times 2 squared is going to be 4 minus 4, 2 cubed is going to be 8 plus 1 half. And then we have 2 to the fourth power. That's going to be 16. Okay, minus, here's my 2 pi sitting here. Now we have 8 times 4 squared is 16 minus 4. Now 4 cubed is 64. Okay, so we have 64 sitting here plus 1 half, and then we have to do 4 to the fourth power. Good grief, I don't know what that is. Fortunately, there's a calculator. Okay, so we have 4 raised to the fourth power. Okay, that would be nice and clever with something. 256, great. 256. Okay. And now we have to go through and deal with some problems, some arithmetic. So we have 2 pi. Okay. Here we have this piece is 32 minus 32. Boy, that's nice. So we have 32 minus 32, which is 0, plus 16 over 2. So we have 0 plus 8 sitting here. Okay. Minus 0. This part minus 0. Plus, here we have a 2 pi. Let's go ahead and figure this piece out here. So we have our 32. Hey, minus another 32. That's this piece and this piece. That's kind of nice. Plus 16 over 2. That's 8. Okay. And then we have minus, and now we have to deal with this. What is 8 times 16? I don't know offhand. So 8 times 16, okay, is 128. Okay. So here's 128 minus, I wonder if 4 times 64 is going to be a nice surprise too. 4 times 64. Okay. That's 256. Okay. And then what is half of 256? Divided by 2 equals is 128. All right. So we have some nice little parts here. So 128 plus 128 is 256. 256 minus 256 is 0. 32 minus 32 is 0. So we have an 8 plus 8. We have 2 pi here, 2 pi here. So we're going to have 16 pi and 16 pi is equal to 32 pi. And that is our answer for this thing. Okay, I think that's what we're doing with this piece here. So that's how you do this kind of a problem. And that's how this tends to go. So done. We're going to go ahead and say I'll stop there. You've listened to me long enough. So thank you very much for watching the video, and I'll see you in the next one. Thanks. Take care.